In this chapter, we will look at detailed dimensions of spokes and nipples, brass and aluminum nipples, and the importance of correct thread overlap. To avoid a wheel building mishap, I'll give you a good tip you can tap. Use spokes proper length for maximum strength and adequate thread overlap. An important aspect of building bicycle wheels is getting the spoke length correct. In this video, I will show you the interface between the spokes and the nipples and what happens if the spokes are the incorrect length. There is a very large amount of close-up detail in this video, so even if you've been building wheels a long time, I'm sure you're going to learn something. Here we see two types of bolts that we're going to compare. This is a typical hardware store bolt. There's the diameter of the bolt, and here's the diameter of the bolt where the threads are. You can see it's the same diameter. Here's a bicycle spoke that you can think of really as a very long, thin bolt, and there's the diameter of the shaft of the spoke, but these threads are rolled on, so you see that the diameter of the spoke is actually larger where the threads are. Here we see a spoke and a nipple in cross-section. That's the length of the threads in the spoke. That's the total length of the nipple. That part of the nipple is the threaded part. This part here is the unthreaded bore. Looking even more closely, we see that we have a total of 19 threads in the nipple, of which 17 are full threads and 2 are what we call half threads, where the slot is on the nipple. We're going to look very closely at the threading of the spoke and the nipple and take some measurements while we're at it. I made really good use of this really cool Mitutoyo digital micrometer, which is accurate to 3 decimal places. The micrometer tells me that the diameter of the shaft of the spoke is 2 millimeters. Where the threads are, the outside diameter is 2.2 millimeters. I constructed this little device to get the next measurement. Here is the spoke I'm measuring, and these two razor blades are entering the spoke from opposite sides into the threads. These two spokes here are holding those razor blades upright. Here is a closer look. And an even closer look, you can perhaps see that the razor blades are down inside between the threads of the spoke. By taking the measurement shown here and then subtracting the width of the razor blade sections, I obtain this value, which is the diameter between the threads. Now let's plot some of these dimensions on a graph and see what we get. We're going to graph what we see in this picture here. Here is our graph paper. We're going to measure width on the y-axis and length on the x-axis. The thread pitch is 56 threads per inch, which is about equal to 1 thread per 0.5 millimeters. We're going to be measuring width from the center line of the spoke, which means that I have where the shaft of the spoke is, the spoke diameter of 2 millimeters, 1 millimeter on either side of the center line of 0. We will regard these two red lines as reference lines, and they are just an extension of the 2 millimeter diameter of the spoke where the shaft is. And the blue line represents the actual dimensions of the spoke where the threads are. So we see plotted the major diameter, which is a peak-to-peak diameter of 2.2 millimeters. Here is the minor diameter, or valley-to-valley diameter, of 1.74 millimeters. So these are all the dimensions I got with my micrometer. The dimensions are pretty consistent across all manufacturers of spokes. The following graphics are not drawn to scale, and I exaggerated the sizes of the threads so that you can see exactly what's going on between the spoke and the nipple. The spoke has 21 threads and the nipple has 19 threads. Using these graphics to exaggerate the dimensions of the threads, here's my spoke with 21 threads and my nipple with 19 threads. Next, we'll look at some pictures of what the combination of the nipple and the spoke looks like as we start threading the nipple onto the spoke. And here is our first picture, and we see that we have an inadequate overlap of threads. Only about 2/3 of the threads are being used. So if the spoke has reached full tension at this point, the spoke is too short for a brass nipple, and it's also too short for an aluminum nipple. When faced with that situation, some people think they can just use a longer nipple. Here we see a 12mm nipple and a 14mm nipple, and you can see that the spoke, when at full tension, extends into the nipple to the extent where those vertical lines are. It's clear from this picture that the thread overlap between the nipples and the spoke is no better with a 14mm nipple than it was with the 12. In both cases, I still have 19 threads from the very end of the nipple to where the threads run out. The only difference between the 12mm nipple and the 14mm nipple is the length of the bore, which is unthreaded. With my 12mm nipple, that amount of thread will be visible in the finished wheel. With the 14mm nipple, I still have the same amount of unused thread, but it's not visible. In this picture, our nipple has been screwed on farther, so we have a better overlap of threads. About 4/5 of the threads are being used, and if the spoke has reached full tension, the spoke is adequate but not optimal for a brass nipple, but is too short for an aluminum nipple. Now let me finish the graphics, but in a minute we'll go back and take a look at this particular picture and see why it is that the spoke is too short for an aluminum nipple. Continuing on, in this picture here I have a good overlap of threads. All my nipple threads are engaged with spoke threads. So if the spoke has reached full tension, then the spoke is optimal for a brass nipple, and it's also optimal for an aluminum nipple. Here the nipple has been screwed on just a little bit farther, but all of those same good characteristics of match between the threads exist. Here I also have a good overlap of threads. All the nipple threads are engaged, but if the spoke has not reached full tension, then a shorter spoke must be used because the nipple cannot screw on any farther, as you can see here. There's no place for the threads to go. Let's now return to this picture and see why it is that the spoke is adequate but not optimal for a brass nipple, but that the spoke is too short for an aluminum nipple. The next few slides will show you what can happen with aluminum nipples if the spokes are too short. Here is a photo of a wheel where two of the heads of the nipples have snapped off. On the left we have a shaft, there's the end of the spoke, and there's the head of the nipple that snapped off, and over here is another case where the head of the nipple snapped off. Here is a reference spoke, and then the spoke under it where the end of the nipple has broken off, and in both cases the length of the spoke is the same. The spoke did not go nearly far enough into an aluminum nipple. And without the nipple being supported by the spoke going all the way through it, the end of the nipple is vulnerable to snapping off. This is a much better picture here where the spoke goes all the way through the nipple, including the last two half threads. It's perfectly acceptable if the spoke goes a little bit past the end of the nipple. You see that we would still have total thread overlap. And this picture here is okay as well. However, if our spoke has not reached full tension, we've got a problem because you can see that the nipple has now run out of threads on the spoke.